Moving on to the third example, it tells us that sine of theta is equal to -1/3, and theta lies in the third quadrant. Find the other two trig ratios. So I'm going to sketch this angle, reference angle in the third quadrant. Here's my third quadrant. I'm going to create a right angle triangle. Remember, theta that we're always talking about occurs between the terminal arm and the x-axis. We're going to draw a right angle triangle to my x-axis. Because sine of theta is equal to -1/3, remember this is opposite over hypotenuse, or y over our r value. So my y value would be a -1. Because we're working in this quadrant, the y value would have to be negative, and our radius would have to be 3. So again, we're going to use Pythagoras to find my x value. In this case, we obviously want to subtract. Okay, I'm going to take -1 squared plus 3 squared plus x squared is equal to 3 squared. So obviously 1 plus x squared is equal to 9. X squared is equal to 8. So now I need to take the square root of this. Okay, and we want to write this as an exact value, so we do not want to find our decimal value of √8. We do, however, want to simplify this radical. So you can simplify this radical by either writing the prime factorization of it, or you can simply ask yourself what perfect square can divide into 8, and that would be the number 4. 4 times 2. So I'm either going to circle my pair or highlight my perfect square. I'm going to take the square root of these values. So x works out to be 2√2. But when I look at my diagram, my x value actually needs to be a -√2 or -2√2 because of where it's located on my coordinate grid. So my x value actually has to be negative here. All right, so now we're ready to write our next two trig ratios. So my cosine ratio is going to be the adjacent, which is -2√2/3. Good. My tangent ratio needs to be -1, which is the opposite, over the adjacent, which is -2√2. Okay, so the tricky part to this is we never want to end our answer with a radical in the denominator. You're allowed to have radicals in the numerator, but not in the denominator. So these negatives are going to change each other and become positive, but I do want to move this radical. So to move the radical, I'm going to multiply the top and bottom by √2/√2. So essentially I'm just multiplying this whole value by 1. It's not changing the value of my ratio, it's just going to change the look of it. So what this is going to become is 1 times √2 would become just √2 over, in my denominator, I'm going to multiply a √2 times a √2. Technically, I'm taking my whole numbers of 2 times 1, which is 2. √2 times √2 is √4. The square root of 4 is 2. And then finally, 2 times 2 is going to give me 4. So my actual tangent ratio that I want to end with would be √2/4.